All right, well, welcome to the section 11.3 video. The objective is to write rules for geometric sequences and find sums of geometric series. Now, before we do this, let's review arithmetic sequences and series. We had two formulas for those. One was to find the nth term, and the way we did that was we took the first term and then we added d n minus 1 times. And then the second formula, to find the sum of the first n terms, we took the first term plus the last term, and we multiplied by n over 2. That was arithmetic. So now basically this section we're going to come up with formulas like this, but for geometric. So let's look at how to do that. So let's imagine a geometric sequence. We got 2, 6, 18, 54. So what's happening? Is it geometric? Well, times 3 times 3 times 3. There's a common ratio, r equals 3. Therefore, it is geometric. So, to find the nth term, like let's say I want to find the 20th term. So it's basically if n equals 20, then I'm going to start with that first term, and I'm going to multiply by 3, so times by 3, but I'm going to do that a certain amount of times. Like if I do it once, I'll get the second term. If I do it twice, I'll get the third term. Basically, 2 times 3 twice gives me the third term, or 2 times 3 squared gives me the third term, and 2 times 3 to the third gives me the fourth term. So 2 times 3 to the n minus 1 is my formula. So let me rewrite that because I got sidetracked by what the actual problem is, because it's not 3 in the formula, it's r in the formula. And then the exponent you raise it to is n minus 1. Now, if we do the 20th term, we're going to get a ridiculously high exponent. How high? 2 times 3 to the 19th power, right? Be 2 times 3 raised to the 19th power. So you'll get something like 23 billion. So geometric sequences rise faster, but your formula that you want to remember, the first formula to find the nth term is this one. Now the second formula is a little more complicated to find and that's to find the sum, Sn, the sum of a geometric sequence. So now the book does a little bit of an explanation of this formula on page 668, but I'm just going to use the formula on this sequence here of 5 terms. It's our same sequence from before. It's the first 5 terms. That's a 4. So the sum of n terms is the first term times 1 minus r to the n power over 1 minus r. So in this case, we want to find the sum of the 5 numbers of the sequence. It's the first term is a times 1 minus r to the 5th power. Well, r is 3. So 1 minus 3 to the 5th power over 1 minus 3. Now 3 to the 5th power is 243. So this becomes 1 minus 243, or negative 242. over -2. And so my answer here ends up being -242. Well, these two cancel out. The negatives also cancel out, and my answer is +242. And if you add these together, you'll find that indeed they do add up to +242. But this is your formula right here, and on page 668 they try to derive it for you. And in our next video, we'll use this to do a couple of more difficult examples, or at least one.